Hello to all of you DevOps and SRE practitioners, as well as those of you who are still striving towards the culture of software as a service. Today in this public webinar in January 2019, I'm going to take you through a tour of Azure Monitor, an end-to-end full stack service for both monitoring and observability. My name is Michael Millerud, and I'm a part of the team of product management at Azure. You may have seen this icon before. This is the icon for Azure Monitor, but over the past years, we've been building more and more capacity for monitoring observability in Microsoft. And last September at Ignite, we've announced a one Azure Monitor that unifies all of those capabilities together. You may have also seen this icon. That's the icon for Application Insights, which is now the APM for Azure Monitor. Much of the talk today is going to be focused around monitoring workloads in Azure, so we'll be looking at Application Insights quite a bit. I know many of you are eager to jump to the demos, but before we do that, let's actually first frame the discussion of why monitoring is so hard and what is the case for having something like Azure Monitor in your arsenal. About 10 years ago, many people didn't think about the number of deployments they have to monitor, the wide range of dependencies, the continuous trends they have to monitor to keep in touch with what the customer's experiences, the outages that may happen underneath them, because all of that was dealt with by the IT departments hosting your service or your software usually. So running software as a service is a very different animal. You also didn't have to deal with terabytes and terabytes of logs. Some of us have to deal with even petabytes of logs. And that didn't require that same level of muscle that is required to run a service at high quality of service, high quality of experience, always being on top of it so that we don't violate the SLA. And oh, by the way, if you do violate the SLA, usually you end up paying money. So monitoring is no longer an option, it is now a requirement. That is what's making monitoring so hard these days. The explosion in terms of the matrix complexity between different environments and the different dependencies that your software has. Azure Monitor makes it much more tractable. I wouldn't say that monitoring has become trivial. It's not easy for sure, but it is now definitely tractable in that all of your data is stored in the same unified way. It's stored using a common data plane, we say. And it's also consumed and controlled using a unified control plane, the Azure portal. And we'll see today a lot of the experiences that, as you'll see, are based on the same exact BI engine, something we call Kusto, KQL, that enable all of this. So whether you need your activity logs, whether you need to look at your platform, whether you want to track changes that are happening to your production, you can do all of that through a unified approach. So monitoring is hard, it's gotten easier, but then there is a much harder piece to keeping up the quality of service where you need it to be for the SLA, and that's observability. So what is observability? It's a term that came up fairly recently in the industry, has become sort of almost popular these days, but it's actually not a new term. So Baron Schwartz is defining observability as something that lets you ask why it's not working. Monitoring is an external feature where you can observe a system and say, is it up or down? Whereas observability is an internal feature of the system. It's a characteristic of the system that lets you ask why something is not working inside of that system. And most workloads, unless they've been designed to be observable, are really hard to observe from inside. Sometimes almost impossible without operating system support. Microsoft has been at the forefront of observability for a number of years, and the Application Insights bulb that's lighting up here is just the conclusion of many, many years of us investing in this space. So let me show you what I mean. This is the history of several trends on Google Trends for various products we've shipped around observability. It all started about 2007 when we shipped a version of Xperf to the public. And then quickly after that, or not so quickly, about 2 years later, we've iterated with Windows Performance Analyzer. And that was best of its class tool. I still haven't seen anything close to that in the industry that lets you see through the entire system at the process level, across processes, down to the network, whether you were interested in GPU or CPU or disk or memory or network, you saw it all contextual with call stacks. So incredibly powerful, also very hard to use, and only really scaled to a single machine. Then around 2010-11, we've introduced the notion of APM, the Application Performance Management pack into System Center. And this is where we realized that as people run more and more complex backends on their servers, they need to be able to correlate all this data and make sense of it. Of course, as the cloud has started to evolve and take form, we needed a solution for monitoring workloads in the cloud, and so App Insights was born. This was about 2015 when we shipped it. The very first version wasn't necessarily the best APM, I would say, but we've done a ton of work and completely redesigned since then the experience. So what I'll show you today is the new reimagined APM v2 that is part of the Azure Monitor. So let's talk about the monitoring landscape sort of from the 10,000 feet view. What does it entail? First of all, you have to deal with infrastructure. So in the previous world of shipping box software, the infrastructure would be up to the IT department, but now we are the ones writing the software, so we have to deal with what the software runs on, and that's infrastructure. Then, of course, there are the workloads, the applications, and Azure adopts a very broad term to the world application. For instance, API app or a logic app, an application that has no UI is still called an app. So be aware of that. And of course, all of these apps, they communicate over the network. So up until recently, to monitor infrastructure, to monitor applications, and to monitor network, you need to use different tools, sometimes multiple tools, to be effective in various aspects of that infrastructure, apps, and network. And what Azure Monitor brings to the table is the ability to consolidate all of that in a single unified experience. That in itself is a huge differentiator when you compare it to the saturated and very fragmented market of monitoring and observability. So you will be able to see whether it's VMs or containers, and when you're using the Azure network, which routes your communication stack, you'll be able to see all of that, as well as applications themselves, including what's happening inside the applications. In this talk, we're going to focus primarily on apps. In our feedback in sort of scheduling this webinar, we've heard loud and clear that you care a lot about monitoring applications, so that's what we have pivoted this around. So what makes workload monitoring such a complicated beast to deal with? Those of us who have been in the industry for a while have seen the transition from a monolithic to the component-based to the microservices-based, the continuous divide and conquer approach that was applied to try and help reduce complexity. But what we ended up with is increased complexity because of the matrix. And once you divide, that means people can build things in different languages. The polyglot culture emerges, and now people choose different tools or different languages and stacks for the job to satisfy different requirements. In Azure itself, there are lots of different types of workloads. So we can talk about web apps. We can talk about API apps, logic apps, all being different types, mobile apps, function apps. Azure Batch doesn't have an app at the end, but it's also a type of workload that you need to monitor. And of course, they all interact with each other. And then they can be built using different frameworks, such as the .NET. ASP.NET has MVC or Web API or web forms. Then there's the Java Enterprise stacks that you can build on top of. And the more recent Spring Boot or the Python or the Node.js developments, which all have as well multiple different solutions. And then there's Golang and ASP.NET Core to go even faster. All right, so there's a really wide variety of options for you to build modern services, and people employ all of those. I've seen many cases where architecture literally lights up with different solutions all working together, all across say, HTTP, which is great, but it's also complicated to monitor. And then there are dependencies on other services like the databases, be it SQL or SQL Azure, MongoDB, Postgres, etc. You have to understand how to monitor all of these database solutions, and there could be multiple in your environment because of acquisitions, integrations, etc. Then all of these are talking between themselves, not directly usually, but through some kind of a queuing mechanism. So you need to deal with things like event hubs and service buses. There are caches in place, like the Redis cache. Some of these things search. So they depend on a lot of different services you need to be aware of that could be either dependencies or intermediaries between your multiple roles in the architecture. And to make this a bit easier to work with, but also to add complexity to this matrix, there is a concept of API management on top, which is a Azure service that lets you unify these different applications under a single umbrella. And we support that, as well as ability to partition assets into subscription and resource groups. And that's for our backend billing. And of course, we have to go and give you at scale views for that, and we do in the Azure Monitor experience. I'll show you all of those today. Then there is a range of operating systems on which all of this can be hosted. And you can be hosting this in either PaaS solutions like app services, or the more complex microservice architectures can go and choose Service Fabric, or you can go for raw virtual machines, or middle ground and use containers. And all of those are different ways to host all of that code that can be built using all of these different languages and frameworks. So a pretty complicated matrix to support. Now, we support all of that, and it's not a walk in the park, and we work hard to make sure this all works. All of these are based on SDKs, and it's on GitHub. So you're welcome to give us feedback on something that you see is not yet supported, and just file issues on GitHub. Now, I did mention that we have a unified data store, but let's double click into that a bit. The common store that Azure Monitor relies on actually has two different technologies for storing data. There is the time series value optimized metric storage, things like CPU, disk utilization, failure rate maybe over time. And then there is the log analytics KQL-based storage that is able to ingest large volumes of streaming unstructured text, index that on the fly, and then make it available to you for open-ended queries. Most of the interaction with Azure Monitor that you'll do will be around log analytics, if at all, because we built all of the curate experiences on top and given you these data-driven insights through the APM. But there's also Metric Explorer, and all of these are available, both metrics and logs, as APIs, REST APIs that you can call to and extract the data. We also have a continuous export where all of the data that we are ingesting, we can also multiplex out to your destination of choice, for instance, Event Hub, and then you can consume it in other mediums. Speaking of other mediums, we recognize that you may have invested a lot of money into other solutions in the market, and some of these work really well for you. So we've spent a lot of time partnering across the ecosystem and bringing a good integration story so that if you're already on Jira, you don't have to move to DevOps just so you can do work tracking. This is the final slide I'm going to show you before we jump to the demos, and I'm not going to touch on every one of these icons because each of them is a good 15 to 30 minutes discussion. Instead, we're going to touch on some of them throughout today's demo, sort of this cursory exploration of Azure Monitor. We have the same diagram in the documentation, so you're welcome to look it up. With all of that said, let's now go and jump into what you've all been waiting for, which is the live demos. Azure Monitor experiences are predominantly hosted inside the Azure portal, so let's go and open that. Pretty easy, portal.azure.com. So now I'm being authenticated, so it's a good time to mention that Azure has great security, and each of your users who will be accessing monitoring and observability information will be authenticated through a separate AAD user identity. You can partition your monitoring data separate from your production assets or whatever assets you are monitoring, so that people who actually do monitoring and diagnostics don't necessarily have access to the production assets themselves, can't interact with them or cannot impact them themselves. So this was a new view we've shipped recently called a home view, but let's switch to a dashboard view. And you'll see a typical dashboard. This one was created by hand, but you can also create these things programmatically, and I'll show you how. In fact, we have default dashboards out of the box. It's a set of tiles like any other dashboard, and you can control the time range of how long you want to look back. So we'll just stick to 24 hours for now. And these tiles come from various different sources inside Azure. Predominantly in this dashboard, I've chosen to use the application insights data as a data source. But some of these are very, very generic, and you can create your own custom queries. So this one is tracking SLA over 8 days. And if I go and take a look of what that actually means, to open up log analytics query that is back in this tile, this tile continues to run this query and calculates the SLA, right? So whenever SLA drops, I probably have an issue that I need to react to. This is pretty bad. My SLA dropped into the 70s and then went back up to 100. And I can define a custom SLA this way, trigger on it, alert on it, or just monitor it. Some of these other tiles are pretty canned tiles, like the application map. If I click on this will bring me into the app map. And many of these tiles lead into the application insights resource blade. So by resource blade, we mean a blade that is attached to a resource in Azure. An application insights is a resource with full RBAC billing and all that jazz. And it has multiple different blades in here. Each of these serve a function. So let's start with the overview blade. The overview blade is there to give you at a glance view over the past trailing 12, 24, maybe even more hours. What was your service up to, right? So we've seen that there were lots of failed requests in the past 3 days, and then it dropped off. If I keep going back, I'll see that the issue has been fixed. But also the server request load went down, so it probably was related to the fact that we were overloaded in terms of load. One of the most interesting features about the overview is this menu option here called application dashboard. So that's another dashboard, but this one is created for you. It's the default out of the box dashboard. So let's go and open that. This dashboard usually has the name of the app you're monitoring and the word dashboard. Of course, you can rename these things. If you change it in any way, it is shared across all the users in your subscription. So they'll see those changes. And if you delete it, next time someone clicks on the button, it'll be recreated from scratch. So what we've done here is we've tried to organize the typical KPIs that you want to monitor for an application. The first column is your usage column. Then you have reliability, responsiveness, and the browser. And each of these tiles leads to the corresponding experience. At the very top, there is a tile shortcut for the overview blade. You have alerting here, smart detection, live stream. We'll talk about these things later. So let's go and jump into one of the most typical things that you would want to look at, and that's failed requests. The prominent metric there is the failure rate, and that's exactly what you're seeing here over time. Again, it's going to be charted over last 24 hours, but you can always go longer range. In fact, we know that for this particular service, if I go 3 days, I'll see that there was a drop-off. So let's just confirm that. Yep, it's here. Let me try and go way back, like 30 days. Still very fast. So you'll notice that this experience lets you pull 30, even 90 days, because you can use custom range to go all the way up to 90 days limit of our retention interactively. And that is a really big deal for those of you who have been doing monitoring for a while. Being able to pull gigabytes, terabytes of data interactively is actually not something that we are accustomed to visually, at least most of us are not. So let's go back to the 24 hours. And then what I see down below is the second chart. We call this the secondary metric chart. And by default, it will show you load. So you can contrast your failed requests versus your total request count. But you can also go and see here CPU. You can see whether you are abusing memory on the machine, what the storage is looking like. And then I can start diving into these experiences, correlating underlying resource utilization. So I see there was some IO and CPU usage to my load and seeing is it failing more or less, right? In this case, there is no correlation. It's a pretty consistent pattern. You can, of course, also use this control to go and move out, just the usual time control and the time brush experiences. Down below, you have a grid we call the operational grid. This is where you can filter by operation. So as I click on these different operations, I'm going to see the failure rates trends for those specific operations. And we've also added spark lines here, so you can contrast them side by side, and you can see that this one is failing more than the other one. Or you could sort by total count and then see where your biggest load is, or you can sort by users and see which of these operations I use the most, right? And it's not always going to be the same, which is why we gave you these internal spark lines to see that. Even though this is not the topmost operation in terms of popularity by users, it is actually failing quite a bit, and you probably should take care of that. And then on the right side, we are cross-slicing your temporal filter and your operational filter to a few sort of distributions, the top response codes, top exception types, the top dependency failures. And that helps you, especially when you're looking at overall, see a bigger picture of what do I have to deal with. So I have a couple of response codes. Some of them are failing with 500s and then 404s. And I have 3 top types of exception types. And I can now go and start filtering and say, hey, I only care about like the SQL exception. And it will say, oh, SQL exception is only really relevant for post-service tickets create. And I click on that. It gives me 4.78K operations. I can maybe even zoom in more. So I trim down my set of operations to look at, and then I can go and investigate. So we call this view a triage view, because in a couple of seconds, I can find when, what, and how often is it failing. And what I'll be presented here is a set of different samples. So this is a good point in time to talk about how do we actually collect this data, the APM data. If we were to go and collect every single request that comes in, the cost of monitoring will be prohibitively expensive, and we actually want to make sure that this is productive and useful to you without breaking the bank. So what we do is we adaptively sample. As your load increases, we'll throttle down our sampling rate, but as your load decreases, we'll make sure that we collect enough. So there's always a minimum set that we collect of your requests. And then here you're seeing some of these samples. We'll include the duration and response code, so you can go and pick one. But we also went and picked one for you that we suggest, and that's based on just how much data we collected around it. Because some of these requests are going to have more data than others. In this case, we actually found a request that was executed as part of the availability suite, and I'll show you what that is a bit later. But the system decided that since we have so much richness around this request, it'd be good to go and take a look at it since it's the typical request with this exception, right? So what can we tell out of the bat about this particular failure? We see that this was the URL that actually initiated, and we see this was called from Central US, and it made a post request to service tickets create, which is what our web app is servicing, and that failed with 500. It tried to do a single SQL request, which did succeed, only took 14 milliseconds. And we can see what the request was because we collect the actual SQL command. And then the second one, that was an insert, did fail. And for each one of these, you will see exactly which SQL dependency is being called and what is the name of that dependency. And when it failed, it threw this exception, system data SQL client, and here's the call stack for it, right? Right here, you can go and just file a work item, reassign this for someone to follow up. You can also go and take a look at other failures that also share the same type and see if they are of similar nature, and they seem to be. And every single time it seems to be the same case, right? So let's go back, and I can remove the filters and maybe look at another one of these. So failing no reference exception is not a good thing. In addition to cross-slicing, you can also just click on the count and straight jump into one of the samples. And this is another example where we are running site and availability test. In fact, most of the usage of this application, and let me show you what that application is. It's a ticketing application, is generated by the workloads that we run for availability monitoring. And in this case, the exception actually has something we call the debug snapshot. So we have this feature inside Azure Monitor that is able to bring memory dumps from failing processes during exceptions being thrown without impact to production. You only have about 20 millisecond impact on a critical path, and then it just keeps going. And that's made possible because of the operating system feature that we're leveraging called shadow copy of the process, where we make a copy of that process, do a dump on the copy while the original instance executes. Right? The beauty of this is that right inside the portal, without ever leaving the portal, without having to remote into your instances and live attach debugger to a process slowing down production, I can go and examine what happened during that particular failure. And I'll have all of the values of the variables right in here, the entire call stack. So that is really powerful if you need to do debugging in the sort of DevOps sense right from production. And if you want, you can also download this and open this up in Visual Studio Enterprise, WinDBG, the tools that are built to debug. It's the same technology that you're familiar with from sort of your local box experience. So other than operations, you can also pivot by dependencies. You can pivot by exceptions. Or you can look at the roles and sort of do a summary on the roles and the instances. And in each case, it's giving you a view that is very familiar, your triage view of when, what exactly am I looking at down here below, and then how often does it happen on the top right side. We also have a performance blade that is very similar to this. And we don't have that much time today to dive into it. I'm going to reference a link to a separate talk where we talk about this experience and what it entails. But let me show you what availability monitoring looks like here, because we've looked at a number of requests that were failing in the context of availability. So the availability blade is where you get to see both the overview over time of whether a specific endpoint or REST API you're monitoring is available or not. And then you can also jump into the details on that with a scatter plot. So I find this kind of plot far more interesting than just sort of just a trend over time, though that's definitely a useful aggregation. Because here I get to see just how slow things are, the higher they are on the y-axis, and whether they're failing or not. And this is a predominantly red scatter plot, so things are failing quite a bit. We've designed it to fail. This is a demo app. You can see then each of these individual rows here representing separate tests. Some of these are being alive tests, so just do a get, and then others are multi-step web tests. A common question is, what do you do if you need to authenticate? So there are a couple of options you can do. You can open up one of your APIs just for a ping alive and do a get on that, or even you can do a get on an auth-based API. It will return that you're not authorized, but you'll know it's live. If you do want to authenticate and execute secure workflows, you'll need to build a web test that knows how to authenticate. So for each of these, I can go and I can dive in and see that it's running from multiple different geos. We support 16 different geos. And in this case, we've onboarded about 1, 2, 3, 4, 5, 6, 7. But you can do more. And I can also go and jump straight into one of these dots by just clicking on it. And what you'll see is it will bring me back to this familiar view of end-to-end transaction details. In fact, many paths inside the APM will lead you to this view, because whether you are triaging performance issues or reliability issues, or looking at your availability data, end of the day, you want to understand why it was failing or why it was slow. In this case, it was slow, and we see that it was slow because of this. In a Gantt chart, you'll see that full Fabricam account took 19.2 seconds. That contributed to the overall 23.8 seconds for your homepage loading from Japan East. So it's at your fingertips, you see what the experience looks like from different parts of the world, and you see exactly where something was slow. And then you see this little icon. This icon represents a profiler trace. Just like with reliability and us collecting crash dumps, we also collect ETW performance traces in production. And I can always go and jump into the profile trace for that particular request. It will correlate the sampled SDK data to the examples that we collect using the ETL and show me the call tree of what entailed in this. And then I can go and I can review some of these other requests and see if it's the same issue or not. It seems to be different issues, and really dive deep into my dependencies and the code I was running while handling them, right? And if this is not enough, I can then also go and download the actual ETL file that will bring me a zip file. And the way this works is our profiler runs about 2 minutes every hour, randomly distributed across different instances, and collects the ETL files out of the process, so it doesn't really impact the workload that you're running, leveraging the operating system, zips it up, brings it over to the cloud for storage. Of course, all RBAC'd. There is a separate RBAC control for both snapshot debugging and profiler traces, so you can make sure that PI level data has different access controls than just regular monitoring data. And then here, I can go and extract this file. And find that there's going to be a bunch of PDBs for symbol decoding, as well as an ETL file. So these are some of the PDBs. And then I also have the ETL file itself. And then I can open up that file in a tool like WPA or Purview, or even just Visual Studio Profiler. It all depends on your expertise with the tools. So my favorite is WPA. I actually was part of the team that was building it, so I am a bit biased, but here is where you're going to see the wealth of what the operating system can tell you about observability of workloads running on an instance. So I can see exactly what was happening, that there was a spike in CPU usage. I can zoom in on that, and I can see which particular processes were doing what, right? I can load symbols and be able to examine specific processes down to call stacks in a lot richer way than I was going to do this inside the portal. Of course, it's a more complicated experience, so you have to know what you're doing in this case. Yeah, this is talk about application insights, not about WPA, but you can look up a lot of documentation and tutorials online about this. You get the actual WPA from the store. Let me show you that as well. So it is right here. Just search for Windows Performance Analyzer. Right. So let's go back to the portal. So we're now 30 minutes into the webinar, and you've seen availability, reliability, and responsiveness analysis that we are making available as part of Application Insights. I've also shown you the application map. Let's talk a bit about the sort of the smarter features of this product. So we have something called Smart Detection, and since we understand the scheme of the data that's coming in from your workloads, we can try and make sense of things like regressions, anomalies that are happening in the streams on failure rates, on responsiveness. And here you're seeing a set of issues we identified automatically out of the box. You didn't have to write anything for this. For say degradation into response time on a specific operation. So it would say that this is the response it saw versus the typical one over the past 7 days, which is your baseline. And if I click, and it also tells you the number of users impacted, percentage of requests impacted. And if I click on this, it will actually show me my average 90 percentile over time and how it regressed, as well as whether it correlates to load. So yes, there was some load increase. That may be the cause, maybe not. Notice every single time there is this icon that shows up throughout the experiences, and that's where you get to see the underlying request that draws that particular chart. So the data is always yours. We give you the canned queries, and you can go and expand on them if you want to. And just know that you can do so much more with KQL. Let me talk a bit about what we collect. So I keep coming back to this view and then leaving it right away. But there is a very useful set of tables here that I think helps understand how Application Insight works. Application Insights is a strongly typed telemetry system that understands as first-class citizens what are traces, such as sort of printf statements, and those would have a timestamp and a message on a severity level, like verbose or warning error. Then you have custom events. This is most for business analytics. It's a whole separate talk on the fact that we have a rich usage analytics in this product. I can also include a reference to that as a separate sort of talk. And then page views coming from the browser. Requests are the incoming requests into your web app versus dependencies, things like going out from your web app, like SQL connections, etc. We collect exceptions. So you'll see that each one of these is a separate table with data on that particular part of the APM data set. And since we understand this data, we're able to draw all of these user experiences, curated user experiences to give you insights into your data, including these smart detections. So here's another one, the abnormal writes, right? And I can again go and dive into the data and look at the actual query that will be, in this case, looking at my exceptions. So it's parting on my exceptions table over this time range, and it's looking for specific problem ID, right? Pretty straightforward. Another really cool feature that we have is ability to see live what's happening. So all the data you've seen so far that's going into Kusto, into KQL, that's historical data. That means we're ingesting it, indexing it, and you're seeing probably about a 5-minute latency delay on that stream versus a live view that is under 2-second latency going from your production straight to the browser in a publisher-subscriber model. There is no ingestion and indexing latency. And both are useful because this is only the past 60 seconds, and that's great for your sort of monitoring of deployments, or if you're doing a load test to see how well things are going or not so well. But you also, of course, want to get the historical view. So the two are complementary, and we usually suggest people to use this view when they need to understand what's going on as they're waiting for the historical view to come in. One of the sort of better ways to visualize this live metrics view is by putting a load test on our instances, and we'll also have this built into Azure Monitor as well. Part of the Application Insights is ability to go and generate loads. We use the same infrastructure that we use for availability monitoring for this. And then I can go and say new and say how many users I want to run in a user load and for how long. Let's just do a minute. I can choose which region to run this from and just say run. Actually, no, I first have to set the URL. So let's go and say hit this one and then run a test. So that will queue up a test very similar to our availability tests and cause it to run. And you'll see if you go back to live metrics how this spikes up. So my load of requests is going to jump from this very low to a lot higher because I am starting to run performance testing on it, load testing. Now, this is of course very basic load testing. You can do so much more, but it's a good way to quickly examine the responsiveness of your web app in production under load. And notice that for every one of the requests, you can see exactly what happens, and then which exceptions are firing with call stacks, what dependency calls are being made with actual SQL command text, right? And if you're making some traces inside, like printf statements, then you can see those as well. So it's a really good live debugger to examine what's happening in production when you're not exactly clear why things are failing. Or maybe a dependency is going down and you will see that a dependency keeps going down on SQL, etc. If you have multiple instances, then here will be the place where you can actually filter by these instances. In this case, I'm only monitoring right now a single one, but then there's another one here, right? So I can go and I can filter to a different instance by clicking here. This is very similar to what you saw in the performance and the failure triage views. Down below is your operational space of what you're looking at, and then above is your temporal trend over time. And then on the right side, you get to see the details. Right, so enough of the pretty pictures of live views. Let's try and summarize. Today you've seen an overview blade with a dashboard that lets you come into these individual experiences inside the application insights. And then we played a bit with some of the monitoring features of failure diagnostics, performance diagnostics. We looked at application map. We have examined availability monitoring, smart detection, and live metrics. There is much more in this product, and we only have so much time, and there'll be other webinars, and we also have other recordings online that you're welcome to go and look up. I'll just briefly mention that there's an entire section of customized workbooks you can create experiences using KQL that look like this. Think of this sort of as a notebook, the notebook that runs the queries and gives you live data on top of those queries. And then there is an entire section for user analytics where you can look at things such as your existing user counts, session counts. You can create custom funnels for conversion rate tracking. There are user flows where you can see how people are navigating your pages. You can look at the retention analysis and more. So there's very rich user analytics, and that will take an entire probably hour to talk about if we were to do justice to this area. All of this data is also available for you to be consumed outside of application insights should you choose so. So I can show you a very quick example of that. If we go back to say failures, and I wanted to go and extract this thing out, I can always say view analytics, and then say I want to do top 3 exceptions, get that query. And anytime you say log analytics view, there is always an opportunity to say export. So if you do export to Power BI, click on that, and you will copy this thing into your Power BI instance. Get data blend query. So now we're just taking the M query wrapper around our KQL. I'm going to go to Advanced Editor and just paste it here. It will load up the data into Power BI. So be it a table like this, which will match exactly what I had here, right? Or if it's temporal data, or if it's a histogram, like something I get in the performance view. So let's try and get something more complicated out, like this view. You can get all of this into your Power BI model and then build analytics on top of that as well. So let's do this again, blend query, Advanced Editor, replace the M query, make a load. And now I'm able to go and charge these things inside my BI report, publish them, share them with management if I need to look at things like top exceptions. So this is my top exceptions. I could even make it prettier. And then this would be my histogram. So I would add count and duration, and then tell Power BI that I actually am looking to graph over duration. And since it's such a narrow distribution, I'll probably need to add a slicer here and tell it to only show me up to a second distribution. And now I see that this is the same distribution that I saw back in Logalytics, or also back in our curated experience right here. Hopefully you got a glimpse today of just how extensive the capabilities of APM in Azure Monitor are, something called application insights. You've seen triage for responsiveness and for reliability issues. You've seen how to do availability monitoring, at least a glimpse of it. There's of course a lot more to talk about. You've seen ability to see right from production straight into your browser without sort of the latency of historical ingestion. You saw ability to do topological visualizations on your dependencies or microservices architectures, as well as some of the smart APM features we have inside the product. There's a lot more. There's ability to do client-side monitoring. There's ability to do usage analytics, operationalize some of your workflows for TSGs, troubleshooting guides. It will probably take a couple more hours to cover some of those areas. Instead, what I would suggest is go to a search engine and type in application insights and your favorite subject, and there will likely be a video or at least a blog post on that subject. And if you have more questions, you're always welcome to reach out. In fact, towards the end of this webinar, we have an entire product team here that's going to answer your questions. So please fire away and type your questions, and we're going to take them. With that said, let me wrap up the demo. With the last slides, we have some action items from here. Well, that was a lot to cover in such a short period of time. I hope you're still with me here and not too overwhelmed. Let's go and actually look at the next action items for you. So Azure Monitor lets you get full visibility across your app, infrastructure, and health. Today I only showed you the application insights layer, but there is also containerization monitoring, there is also infrastructure monitoring, and there's also network monitoring inside Azure Monitor. We haven't even had enough time to show you all of the application monitoring. I did show you how to discover and fix issues using the diagnostic analytics tool. So you've seen the triage views, and you saw the ability to jump into end-to-end transaction view, and from there all the way to code that lets you either file a work item on developer to fix or have them go and follow up and investigate on something that you've triaged as important. I've showed you dashboarding, which is how you can track KPIs. You can do this inside the Azure portal, or you can create Power BI reports that refresh straight from your application insights live data. And there is an entire workflow that also will take an entire session on how you integrate this into your existing processes with other tools that are part of your DevOps infrastructure. So getting started is free. In fact, we are throwing in 5 GB per subscription per region of data for you to play with, which is great for dev test use cases. And you only really start paying when you go production on the load. And even then, it's not that expensive. So go and look at the latest pricing on the Azure Monitor pricing calculator page. Here are some of the links for you to go and explore. The AZMon overview will take you straight to our What's New page inside Azure portal. And then we also have a course put together in collaboration with Pluralsight. It's completely free. So go sign up on Pluralsight and go through that course. It's going to teach you the basics of KQL, how to get started. It's a good way to get into language if you want to go beyond the APM curated experiences. Of course, you can also just jump into the queries that we used to build that APM, learn from there, and expand on that. Okay, so with that, let's go and actually go into our Q&A session.